Super-capacitor or ultra-capacitor. Super-capacitors are used in automobiles, buses, trains, cranes and elevators, where they are used for regenerative braking, short-term energy storage or burst mode power delivery. Ultra-capacitor construction. This diagram shows the basic construction of an ultra-capacitor. A capacitor stores energy in electrostatic field when charged. To store a significant amount of energy, very large capacity, that is in kilofarads range, capacitors known as super/ultra capacitor are required. The capacity of a capacitor can be increased by increasing the area of the electrodes, that is plates, and minimizing the distance between them. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. The increase in capacity of an ultra-capacitor is achieved by coating a layer of activated porous carbon on metal foil electrodes. These foils are separated by a paper separator and dipped in an electrolyte. The paper separator prevents electrical connection between the electrodes but allows free movement of ions across it. When connected to a DC voltage source, the electrons accumulate at carbon coated on foil attached to negative terminal of voltage source. These electrons in turn attract positive ions from the electrolyte into the pores of the carbon on that electrode. In the other electrode, meanwhile, positive charges accumulate, attracting negative ions into the pores of the carbon as shown in figure. The activated carbon's huge surface area comes from the great porosity of its microscopic nodules. It enables the positive and negative ions migrating through the electrolyte to find plenty of nooks and crannies to occupy as they insinuate themselves as closely as possible, that is atomically close, into the oppositely charged carriers inside the carbon. Notice that this is actually a pair of capacitors connected in series. At each electrode there is a separation of charges, electrons and positive ions at negative electrode and positive charges and negative ions at positive electrode, each constituting a capacitor. So at each electrode there are two layers of charges, which is why ultra-capacitors are also known as electric double layer capacitors. A supercapacitor oblique ultracapacitor has much better cycle life, typically above 5 lakhs compared to batteries. These ultracapacitors can be charged in seconds rather than hours and can function at extreme temperatures. Commercially available ultracapacitors can store about 3 to 4 watt hours per kilogram compared to 60 to 70 watt hour per kilogram typical of nickel metal hydride batteries or 110 to 130 watt hour per kilogram delivered by lithium ion batteries. An ultracapacitor with battery-like energy density would be irresistible to a large number of users, especially hybrid electric vehicles. With their lightning fast charge and discharge capability, ultracapacitors could handle the power surges needed for accelerating, allowing the use of a smaller battery pack in the vehicle and eventually perhaps no battery pack at all. It can also be used for stop and go operation in hybrid gasoline cars. In this operation, the gasoline engine is extinguished at stops and started instantly against when required. Ultracapacitor and a powerful starter motor would instantly jolt the engine back to life. Such vehicles would also make use of regenerative braking for charging of ultracapacitor. In fuel cell powered cars, ultracapacitors may play a very important role. Fuel cells by themselves deliver power too sluggishly to briskly accelerate a full-size car. They must be mated to a faster energy storage device, and for this, coupling with ultracapacitors are superior in many respects to batteries. Request: it is hoped that this session was useful to you. Please press like button. Please सब्सक्राइब दिस चैनल। बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा।